And last but not least, we're going to look at number 28. So, and I ask you to read example 4 first, so you may want to pause the video and go and read through example 4 before you go through this with me. So number 28 says the radius of a circular disc is given as 24 centimeters with a maximum error in measurement of 0.2 centimeters. So the measurement of the radius could be off by at most 0.2 centimeters. Now that could be measuring 0.2 centimeters too short or 0.2 centimeters too long. Part A says use differentials to estimate, and there's a typo there, the maximum error in the calculated area of the disk. Okay, so again, we're going to use differentials to estimate. So the area for a circular disk is a function of the radius. That would be pi r squared. And the rate of change in area with respect to the radius is 2 pi r. Just using my shortcut rules, remember that pi is a constant, r is the variable here. So I bring my power down, raise r to 1 lower power, and then dA, differential of area, is 2 pi r times dr. Now, note to self, in this case, dr, which we could think of also as delta r, is 0.2. That's how much the radius might be off by. Now, dA is an estimate for delta A, which is the actual change in area. That would be the area calculated at 24.2 centimeter radius minus the area at a 24 centimeter radius. I'm going to estimate that with dA, 2 pi times radius of 24 times dr, 0.2, and if you multiply all that together, you should get 9.6 pi square centimeters. Think about why the units are square centimeters, which again, if we don't have a sense of what that is, it's about 30 square centimeters. Okay, so I'm finding a change in area. Each area is measured in square centimeters. Okay, and then part B wants us to find the relative error and the percentage error. Now we can do relative error in general. And relative just means relative to the overall area. So delta A over A would be relative error in area, which is approximated by dA over A. And dA, we said, is 2 pi r dr. And area, we know, is pi r squared. So the pi's cancel out, and one of the r's in the denominator cancels with the one in the numerator. And we have 2 over r dr, which actually, in this case, the way we want to see it is 2 times dr over r, because dr over r is the relative error in the radius. So in other words, the relative error in the area, relative error in area, is about twice as big as the relative error in the radius. That's what we just figured out. And that's in general. We can find actual numbers for these. So the relative error in the radius again, that's given by dr over r, which is 0.2 over 24, which as a decimal is 0.0083, with the 3 repeating. And again, I would pause the video and actually check that on your own technology, or 0.83% as a percentage. The relative error in the area Again, relative meaning relative to the actual amount of area. That's dA over A, but we found out that's twice the relative error in the radius, so that's 2 times 0.0083, also known as 0.016, or as a percentage, 1.6%.